let's get started. Presumably there might be some questions, some of which I probably can't answer. There is one typo on the exam, which should have been posted on the wiki by now, and so you can look that up there. Any questions? What's number 2? Like I said, some questions I probably can't answer.
Question I'm supposed to do the histogram. The question says histogram, but it seems like you want us to be like, because if we've been in sorting them.
I was thinking of each individual.
Each in.
No, just United States won 80 medals, right? And USSR won 49 medals, and Sweden won 329 medals. Right? Yeah, that's classifying, right? Right, yeah. I mean, yeah, basically, if you have 2 clusters, then you figure out which cluster is which one, and then right. And what's part 3? Well, but when you're doing linear regression, yeah, you can write an equation, which is the model, right? When you're doing clustering or classifying, then you don't have an equation. So in the context of, clustering or classification, what does it mean to have a model? Yeah. Well, my question is the answer to your question. Ask yourself, what does it mean to have a model when you're doing classification or probably not. Well, our data has already been marked, right, as what movie they're in. So you can compute from a test set how many, what cluster is it in, and then was it in the right cluster or not, right? Do they give you different results? Any other questions? No, I don't. You can. I might not answer them. That's the hard question to answer. Well, it's supposed to be an exam, right? So I have to look at the question and think about is this one that So although you want me to talk about problems on the exam, I'm going to move on to talk about something else. And in particular, I want to talk about Spark and running Spark on a cluster. And in general, running Spark in a notebook for me is somewhat unsatisfactory because when it hides everything, how do I know what it's doing and how does it work on a cluster? And oh, by the way, when you run it on your machine, it's like slower than just using pandas, right? Because you have to do all this extra work. And so I want to talk about that. And so it also becomes important to understand what part of your code is being run where. So here's an example. Okay, just creating a range and then showing it. So the column name's ID, right? This is just information. And so here what I want to do, I want to create a function, and the function I want to run on all the items in my data frame. And my function does several things. I just want to basically count the number of times the function is called. And then just to see what's going on, I want to print things out. And of course, since this is Python, I want this function to use this counter, so I have to declare it global. Otherwise, it just creates a local variable, right? And then all I'm doing is, okay, I'm creating a Spark session. I forgot to remove that. And now I'm going to print out when I start, and then I create a range of the 16. And then I coalesce it. What does coalescing do? It reduces the number of partitions I have. I haven't quite figured out why in PySpark, when I run it on my single machine, sometimes I get 100 partitions. It's like, oh, and this is becoming more interesting, but I haven't figured out the answer yet. And then there's a for each, which basically you pass in a function and it's run on all the elements in your data frame, right? And then pass in the item, and each item is basically a row object. It's not a individual item. And so then to get the value of the item, I have to do the row dot then the column I want, right? And then I press start and end, and then I print out the counter, right? So when I run it in a notebook, right, the output I get in the notebook is start, end, and 0. That's it, right? All these print statements don't go to the notebook. Huh? Yeah, really. But these two do, right? So the first issue is why, right? Oh, and the answer is this is being run on the master node, right? And this function, the for each, has been run on a worker node or a slave node, right? And the output to the master node gets put in the notebook. So that's why we're not seeing those print statements. Now, in the command line, when I started Jupyter Notebook, all this output is shown. I mean, it's a separate process, right? So how is it going to connect up to, right? Your master will connect to that process and see the information and get it, but it doesn't get the standard out back. It just gets what requested, right? And since I have to coalesce it into 4 different partitions, there we go. We get 12, 13, 14, 15. And the counter goes from 0 to 3. And then here's another partition, 4, 5, 6, 7, 0, right? And so what's happening, right, is this count function is being run on the partitions, right, on the worker nodes. And each worker node starts out at 0. And when I'm printing out this counter, I'm printing out the counter on the master node, which hasn't been incremented at all. So part of what's happening here is that, well, it's hiding what piece of code is being run on the worker nodes and what code is being run on the master node. And so you have to be careful because, right, when I say for each, when I do aggregate, when I do all those transactions that we could do on a data frame, that's all be done on the worker node, not on the master node. Yes. Yes, right? You're going to specify that. So what's happening is, when you run this program on Spark, right, it's doing a lot of work for us. And so this program is being duplicated on all the worker nodes. Whole thing, right? But how else going to get that? I mean, that code has to be in the worker node for it to actually run that code, right? But the difference is on the master node, we execute the entire thing, right? But the worker nodes are only responding to transactions that we're doing from the master node. So the worker nodes are not running the program from top to bottom. If they did, we would just do the exact same thing and get the exact same answer from all the worker nodes, and what's the point? I mean, why do the same thing identically, right? So it's not until we do this for each that the worker nodes are doing something. Right? So it's important to keep this in mind, right? And the notebook is sort of hiding that from us, right? It's just like, oh, I just run the code and it all works, right? So it is possible to run notebooks on AWS, right? I have not yet got it to work successfully. I'm not sure why I sort of know why they do it, but it seems somewhat counterproductive because, well, when you start up a cluster in AWS, it takes like 5 or 10 minutes. Well, you have to schedule it, and you have to, there's all this sort of stuff going on in the background, and like, you want to sit there for 5 minutes to wait for your notebook to start running? It's like, and then you start running different cells, and it's like, well, you've got a cluster of 10 machines or 100 machines waiting for you to do something. And if what you're doing only takes, a second or two, why are you bothering using a cluster? You presumably start doing larger jobs. It may take you 10 or 20 or 30 minutes, and you're going to be sitting there waiting for the result. And why not just submit a program to run the program, and then you get the results when you're done? So I want to go through sort of steps to first, how do we mimic what we do on AWS on a local machine rather than just run it in a notebook? And yeah, we need a program, and we need to be able to say, look, here's my input file and here's my output file. And we don't want to hard code that in our program because you may want to run the same program on different inputs, right? And you may modify that program and then you want to use a different output file so you don't clobber the old one. So here is a sample program, right, that has minimal dependencies. And so there was a function I call print 5000. I could have done the open, but at some point we want to, say here's the input value and output value. And it's like, okay, that's why we got functions, right? And so all I'm doing is I'm creating, right, a session, and then I'm, just computing a range and doing something to it, and then collecting results, and print that out, right? So now if you've downloaded Spark from the Spark site, right? If you then go and look at, there's a bin directory and there's an sbin directory, and in the sbin directory, there is a program called Spark Submit, and when we're dealing with PySpark, we can just give it a Python file which runs Spark. If we're doing Java or Scala, you have to get a jar file and then tell it which is the main class in the jar file to run. And then what happens is it's going to start up a master, and it's going to start up worker nodes, and then it's going to run your program, and it's going to shut everything down. And you get lots of output telling you what it's doing. It's running this, it's submitting this application, it's doing a bunch of stuff, right? And actually, I counted. There's 99 lines output you get. Much I didn't count is, the program that count for me. And then in the midst of that, you get this output, which was not done by a logger, and you can tell because the logger gives you, date, timestamp, and then the log level, and then, right, I'm just getting a raw output, which to me is a little more satisfying than running a notebook. At least you can see it's doing something, right, and all the stuff you're doing. But now we need some way of passing parameters, right, to our program. And so there's a couple standard ways you can do that in Python. One way is with argparse. And so what's happening here is we're saying, look, input, and we give a default value if it doesn't exist. Same thing with .o or for output. And then we can parse the values, and then we get input and output values. And so now this function I can call, and it will look at the command line that you pass it, right, and pick off those flags from the command line for you. Just to make it easy to say, read this file. Of course, if we need 3 or 4 different input files, we're going to modify this, right? And so the sample program just should print things out, and right. This sort of basic Python command line argument stuff. And so sample examples, right, of what happens when you call it different ways. So a slightly more complicated program where what I'm doing is, again, I'm going to read from the command line, the flags to know where to put the output. So down here, the underscore means I don't care about the input because I'm not going to use it. And then here's my program. Again, I create a Spark session, and then I'm just doing I'm creating 0 to 4,099, right? And then and multiplying by 2 just to do something, and then I'm going to write it out, right? And you run it, and yeah, you get this, right? 99 lines of logging output. And we can configure Spark to filter out different log levels. So if you don't want all the info, you can, the configuration file you edit and then say, no, just do errors or higher level. But now let's go one step further. Rather than have this Spark submit, start up the thing and then shut it down, let's start up a master node and a worker node, and then submit our job to the master node to run, right? So there's a number of different commands we can use. One is start master.sh, and when you run this command, again, it's in the sbin directory of your Spark install if you download it from Apache sites. And then this starts up a master node on your machine. And there's actually, it also runs a web server, so you can see what's going on your jobs. And that line is important because it tells you how to connect to your master. So when you do a submit, you know how to submit to it. Also, when you want to, there's no workers, so I really can't, we need some workers, right? So that URL becomes important. And, when we run some applications, we will then see what's running and what's completed, and we get information about what's run and what's completed. So now, to start a slave, right, we need to specify, I want to start a slave or worker, and I need to tell it where the master is so that it can basically, connect to the master so the master can use it. We can use the same programs actually to run it on a cluster. It's slightly more complicated because you have to start remotely on one machine, and then the other machines you have to log in, and right. And of course, you do that a couple of times, you realize this is painful. So you want some sort of cluster manager, so you can just say, give me 5, 1 master and 5 workers. But I feel a little bit about this because now it starts being clear that we need to configure things, right? And there's a separate process being run to do these things. And now once you've done that, you go back to the master website and live workers 1, how many cores you got? There's 8 cores. Well, it's only a 4-core machine, but again, of course, Intel is, with all their tricks, are making it look like there's 8 cores, right? And then it lists how many workers you've got. And it really doesn't allow you, it only allows you to run 1 worker on your machine. If you want to do more workers, you need other machines. And then, well, now we can submit our job to the master node using Spark Submit, but then we have to tell it, okay, where, how to connect to our master, right? And so that's my master, there it is. And then, where is the program you want to run? And then any flags you need, in our case, where to put the output. And after you run it, then it's okay, completed applications, right? There it is. Get some crazy, one was submitted, right? Finished, how long it took, etc. And then we can go in and, click on the application and get more information about what happened. And there it is, the application. And then it gives us, the worker, and then we can get a little more information from there. So now we can start a master node, we can start up a worker node, and we can submit jobs to the master. And if we really wanted to, we could do this manually on a cluster. And yeah, there's various commands, right? There's start master, start slave, stop masters, stop slaves. But if you're doing this on, a single machine, then there's start all, stop all. It's a little easier than having to first start to master and then start to the slave. The Spark submit has a number of flags. If we're dealing with Java or Scala, then we have to specify what class is the main class in our program, so it knows which one's to start. Using PySpark, we don't need that. Which master we want to use, and that could be local to the machine or it could be a remote machine. Deploy mode, there are quite a few parameters we can tweak on Spark, so the configuration file, and we can specify those values, some of those values here. You don't want to do them all because there's like 50 of them, and the command line gets awfully long. And then again, if you're running in Java or Scala, we need a jar file. If we're running in PySpark, we just need the program we want to run, and then after that, just whatever command arguments your program needs. When you create, Spark session, there's all these properties you can set. One key one is a master. So if we go back to my program, notice I did not set the master here. I just, gave it a name and then I said get or create. The reason for that is the standard on Unix or on servers is when you have an application, there are usually 3 places you can configure it. There's a configuration file that reads a bunch of these properties. But then the command line, you can overwrite any property you want that was in the configuration file. And then usually you can then overwrite any property you want in your program. All right, and so your program settings take priority. And so if I were to specify which master to use, it's going to use that master. Right? And so typically you don't want to specify the master in your program because that means when you're trying to run a different machine, you have to modify your program to use that one. There's various, ways of configuring it. Local, just run it locally. how many, the bracket K tells you how many workers you want to use. Optional argument, how many failures, we haven't talked about that, but, when you're running on a cluster, say 50 machines, what happens when one machine stops working? What happens, right? The asterisk means how many logical cores you've got, right? So my machine is 8, even though there's only 4 cores. And then we can start specifying a remote machine, right? So if you've got your own cluster, then it's Spark : host port name, right? And we'll talk about Zookeeper later. Right, so yeah, different examples of just using default values, use a local machine with how many cores you've got, or connecting to an existing master node. So far, so good? Okay. Most of the stuff we're doing is pretty small. We're not writing large pieces of code, but at some point you might build up, library of things you want to do, and you may want to bundle up in functions so you can call them elsewhere, right? And then there is a flag --py files, which you then can list, a set of paths to individual files, or to a zip file, or to a special python.egg file, right? Where you basically take a bunch of, that's the Python specific way of bundling Python code together. And like I said, the precedence order is the configuration files on the bottom. You can override that with command line, and then you override that in your program. So yeah, and generally you don't want to set the master, right, in your program, because typically you want to run it on your local machine, make sure it works, and then you're going to move it to a cluster, and so the master node is going to be different. The default is when you write to files, it won't overwrite existing files. So when you run it, you'll just get an error message, exception. And, we can override it with, changing the mode to overwrite. If you're testing your program out, probably doesn't matter, but when you're running it for real on real data, you probably don't want to overwrite files. This becomes tricky because remember, our worker nodes are separate machines. What happens when I do a print statement? So Spark does have logging. It uses a standard Java logger. It takes a little work to get access to the logger in Python because it's really Java code, which causes a problem which I don't know how to solve yet. So here's an example of getting the log, access to the logger, and then we get the log manager, and then we can get a log, and basically you can specify different logs with different names, and then we set different properties for each log, so I can have different loggers doing different levels of logging if you want. And then when you run the program and those 99 lines of code, your log statements will be in there too. And you get the log, timestamp, and then whatever name you gave the log, and then whatever you specified, right? Right, so this works fine, right? Give me a logger, give it a name count, and then, I just say start and run it, right? When I run the logger on the worker, I get an error. And the reason is, right, we saw before, right, we're working on the master and working on workers, right? And my starter class, right, I gave an example where we're working on the count, right? But the counter was a number, right? But now, what happens here is this is a Java object. And how does that Java object get to, how do you pass that on to the, right? Well, really what you do is you run this on the workers, but then you need that Spark context. And the Spark context is not on the workers machine, it's only on the master machine. And so one of the problems I haven't solved with PySpark is how do we do remote logging on the worker nodes? And it basically says it doesn't exist, right? The Spark context doesn't exist on the worker nodes. Now I know how to solve that problem in Scala, but I just haven't found out how to deal with it in Python. The other thing I haven't quite figured out is when you're in Java or Scala, the standard logger has various levels. And then how do you specify the level? You basically, levels are in the log class or level class. And so, right, you say level.off or level.fatal to specify a particular level you want to interested in. So here is example in Scala. So the syntax is going to be slightly different. If you just get rid of that stupid object thing and replace the curly bracket with a colon, and then get rid of all the vars or vals, you pretty much have a Python program. But the hard part is when I get my logger, I say set level, and what level do I set it? Well, there's a constant that you call, and the constant is level.air, but level is a Java class, and so now we need to access that Java class from inside of Python. And then it's like, well, how do I know what classes are available in this Python program? Or we could also try and figure out what the actual value is by going to the source code in Java. I just haven't done that to. So I don't know how to set the levels. I have a vague idea how I might be able to do it, but I haven't had time to worry about that. we can go to the configuration file, configure it to what level of logs do we want to see. So that's probably one way to solve the problem of having to muck around with Python and Java combined. And there's a configuration file. And again, when you download Spark from the Apache site, there is a directory which contains all the configuration files that you can set. And now, again, this is Scala, and Scala has the same problem. When I run a log method, trying to log from a worker, I get an exception, the same exception. But I know how to get around that in Scala. And the answer is one of these weird things. We have to make it serializable. Why? Because it has to be serialized so the master can send it to the workers, right? And then we have to make it transient because we don't want to serialize the actual thing because we don't know what it is, right? It's not our class, so we don't have control of serializing it. And then we want it lazy because we don't want to evaluate it until it gets over there, right? And then it's like, okay, but in Scala, I've got direct access to the Java classes. And I know they're going to be available because I'm running Scala, and Scala runs on top of Java. So it's just, give me the logger, right? And now I can call it. How do I do all this in PySpark? I have no idea. Right, then I can just call it, right? Distributed logger.log and warn, and it all works because it's not being initialized on the master, and that class can be serialized and sent to the worker. And then when I call it, it's actually initialized. And on the worker, we've got access to all the Java code because it's running on the JVM. And then I get, all the messages, and again, the output's not in order because we're running on multiple machines, right? So now I go back to, right, basically our first program, right? And now I can actually run it not in a Jupyter notebook. We can run it on we could submit it to a master node running on our local machine. And when I do that, right, I get an error message. Because it says, push counter. So the behavior is different from when I do Spark submit and I start up the master and worker at one shot, and when I start up the worker and the master and then submit it to the master. Right. So not only you have to be aware of what code is being running where, but you have to be careful of what happens when you submit it different ways, right? Because again, we're assuming, right, that there is a global environment that this function counter or count exists in. Spark has a few ways of communicating some values directly between a worker and the master, but not the same way as a global in Python. And they operate slightly differently than you expect sometimes. Right, I mean, there's line 5, I didn't know where it was, right? Yeah, another example, you've probably forgotten, but I had use this data set where it's a flights between flights in the United States, which country they started and which country they end up in, right? And how many flights there were. And so I'm going to give the same data set and just do something with it, right? So I'm aggregating and get the sum. And I'm using coalesce. Why? Because otherwise I get over 100 partitions, and I haven't quite figured out why there's 100 partitions. Then I write to it, and so now I, and basically a main which reads the command lines, get the input of files, and I, call the function. And one of the main reasons for this program is when I go to Spark, I want to be able to, or AWS, I want a program I know works, which I can say, here's the input, here's the output, because in general, you're going to want to pass in an input file or input files, right? And an output file to get the results. And so here is one of my sample programs that I actually was able to get running on AWS about an hour ago. And so, yeah, again, once I have the master and worker nodes running, I can do Spark submit and tell where the master is, and here's the program you want to run, and then the output and the input. And I get, since I asked the coalesce to shrink it down to only 4 partitions, I only had 4 4 output files. Okay, that's a good question. When I run it here, right, it's all a local machine. So then I just specify, right. And so what's happening is I put them in the directory I'm running the program from. But you can't do that in AWS, right? And so the AWS, they have their own file system called S3. And so first you have to upload those files to S3 and create buckets. And then you have to, instead of specifying, you say, S3 : / and then your bucket name and then the file name, right? And those buckets are accessible on all their machines. They definitely need to work on the soundproofing of their rooms, right? Without that coalesce, right, I run the same program, I got 102 output files. Like, I don't understand why there's 102 partitions. And initially I wasn't worried about it because I thought, it's just some weirdness in running PySpark on a local machine. But when I run AWS, I get the same number of output files. Like, no, I only asked for 2 workers. So it's something I have to figure out, what's going on. I don't quite understand why. Is 100 what? Well, it could be, but when I do a similar thing using Scala, I get one output file per partition, which is, and each worker has a one partition, right? So, I mean, you could be right, but just, yeah, why is there a difference in what's going on, right? So, Amazon Elastic Map Reduce, allows us to run Spark and a number of other programs on clusters. We can specify what clusters, how big a cluster we want. And you can create a free account to run some programs. If you go through the student program, they should give you, right, a certain amount of money. The first year I ran it, we got charged. The second year, we weren't. I was like, I don't know. Well, actually, if you just, in theory, if you run it, you should get the 12 free months the first time you sign up. But if you sign up for this educator discount, since I did that, I haven't gotten charged. Yeah, you go to educate, you get a discount. And this pricing is old. I'm not sure what it is now. And I think these two levels are gone. They don't, I mean, each year they sort of get bigger, more machines, and they get rid of the older machines. And there's on demand and spot. Spot market, you basically submit the job and say, run it when you've got available time, available machines, or low load. Demand is like, we'll do it right now. But 10 cents per hour is, although I have, they used to charge you per hour. I mean, round it up to the nearest hour. But now I think they charge you per minute. And yeah, basically you run your program locally to make sure it works. Once you have all the bugs worked out, so you can upload your program and your data to S3, and then you can launch a cluster and then specify, I want to run this program that's located here, and here's my data files, and then it will spin up a cluster for you and run that, and you can run multiple jobs in the same cluster. After you create the cluster, you can add more jobs to it. When you log on to AWS, there's a console you go and you can do all this, the wizards and say, do this, 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 this. They also have a command line tool, command line interface where you download a program on your machine and then you can configure it there and send it to. That's a bit more complicated because you have to have an account and you need a certificate, and they don't want just anyone sending remote commands to, right? And we can write programs to do it. And in PySpark, we can actually now create a notebook and run it on their machines. I've not had it. That was low priority for me, but I'm not quite sure how much sense it makes. So I tried it once and it didn't work, and then I haven't figured out why. So they've got their own file system called S3. It is different than the file systems you've been using, unless you've been doing some interesting things. You create buckets, and the bucket name space is global, which is sort of weird, which means everyone using S3, it's like Gmail, right? There's one global namespace for all Gmail accounts on the planet. I mean, really? How does that work? They do the same thing, right? So, which means that when you create a bucket name, it checks to make sure that no one else has used a similar bucket name. Yeah, it's like, really? But that's what they do. And so all my bucket names start with RW to help differentiate it from other people. So it's RW and then other stuff. And yeah, you can access those files. I mean, you can go, again, there's an S3 console. You can log on to the web page, the web browser. I don't do that because, like, I mean, I want to upload files into a web browser and download them. So I have a client that allows me to access the files directly. And if you want, you can actually write a program to interact with S3. A lot of people do that, right? I mean, it's a very cheap storage, and so when S3 came out, I know people who are like, okay, I can just write a little program and then upload my entire hard drive to the, right? It is so cheap. Right, when you log on to their S3 console, right, I can create a bucket, delete a bucket, empty a bucket. And also various regions. So when you create your account, you usually place in a region. When I create my account, they put me in the US West location, which makes sense. It's up in Oregon. So when I create buckets, I make sure that they're in US West. It really doesn't make a lot of sense to, put my bucket in the East Coast or in Europe or in Asia, and then try and access it from Oregon. And then when you try to do it right, it's like enter the name and what region you want, and you can set various access parameters. And again, these costs are several years old now, so it's fairly cheap to store stuff. 2 cents per gigabyte. I mean, again, this was like 2 years ago, so the good news for us is that Amazon, Google, and Microsoft are in a price war to try and convince you to use their service, so it keeps on going down every year. Yeah, and they talk about objects being on the file system, files. And the files have, data, metadata. And again, I haven't checked the current setting, but each file can be up to 5 gigabytes, which is big enough for us. And yeah, the bucket names, like I said, the global namespace, so you have to, and the limited number of buckets you can create. And the various rules on what the names can be in. And then we can have a key, right? And that key is a unique identifier for a particular object, which uses its name and allows you to then actually access that from a URL, given the right credentials, or you're making the file public, which you probably shouldn't do. There's been a number of security breaches because people weren't paying attention to the security on their Amazon file system. So there's been several government agencies that had stored lots of data on S3, and they forgot that all the files are public. And so there's a access control list, so you can determine who can read or write. And if you use this for real, you got to pay attention to this because you don't want to. I don't know about what organization you may work for, but San Diego State, if you leak student red IDs, they have to send a letter to every student involved. And so they will not be happy when you tell them that. So if I lose my laptop, I basically have to resign because they are not going to be happy with me. So the one difference that S3 has that you're not used to is basically a distributed file system. In the sense of, if I'm going to run, Spark on a cluster of 100 machines, and I got this big data set I'm going to read, right? Then each worker needs a piece of that, right? So how do those workers access that file? So it's a distributed file system, and once you do that, things change. Because if I write to a file, it takes a while for that write to propagate across their entire network. And that leads us to the famous CAP theorem. Which basically says you can't have all three of consistency, available, and tolerance to network partitions. Well, think about it. If we want, whenever I read a file on a distributed file system, I want consistency. That is, all machines will always get the same result when they read it. The only way to do that is when I write to the file, I have to lock the file on all machines first, right? And then I can write to it, and then I can release the lock, which reduces availability, right? Because I have to, if I got 100 machines in my cluster, I have to first request a lock from all those machines. And if one of those machines is writing to it, I can't, right? Or they're reading to it, then I have to wait until they're all done reading. And so we have to wait till that file becomes available to be locked. And then when I'm doing that, no one can access the file until I write to it and then propagate the changes and unlock it, right? So there goes my availability goes down. So if I want every machine to be able to access it all the time, I can't have consistency. And then tolerance network partitions, what happens when I've got 100 machines and there's a network problem and 25 over there can't talk to these 80, right? Now what happens? Now what do we do, right? Because they may want to write to it, right? And what happens if I say, okay, well, forget those 20 machines, just work on these 80, and we're not writing and modifying it, and all of a sudden those 20 come back because the network connection was just temporarily broken or it was slow for some reason. Then what do we do? Because I've written this, changed this file several times, and they have an older version. And oh, by the way, I mean, these 20, like, well, they're gone. So what do? Do we stop or we continue working, right? And so they may have been doing their things and they've modified their ways. Now what do we do? Right? So consistency, what do we mean, right? Here, machine 2 changes the value, and now if you allow machine 1 to read the value, it's not consistent, right? Partitioning, okay, we start out here. All of a sudden, network goes down. 2 machines can't talk to each other temporarily for some reason. Who knows why? And in all these discussions, people talk about machines going away or dying, right? But in practice, often what it means is it was just slow. How long do you wait for a response to decide, okay, they're gone, right? Do you wait an hour? Probably not. 5 minutes? You wait a minute? You wait 30 seconds? Um, um, and so when we talk about partitioning, what we're really talking about is latency, right? The latency becomes too high. And so basically, yeah, partition is, well, we're trying to communicate with that machine and the response took too long to come back. And so we can specify that time frame, and when that time frame, we assume that they're gone, and then do something else. This is probably a good place then to stop. And we can spend a minute listening to the drum beat.